So here we have our first easy way in to non-evenly distributed forces with a triangular distributed force that sits on top of a 9-foot long beam, and it carries 60 pounds per foot at this high point and 0 pounds per foot right here, and everything else in between. And our goal now is to find the support reactions. As always, we start off with our free body diagram, and a free body diagram for a rigid body always has the dashed lines added to it. And I bring down my forces next. So let's use this triangular force with 60 pounds per foot right here. So that only applies here at this location, 60 pounds per foot. And of course, I need to include my support reactions. So I assume that RAY goes up. I assume that RAX goes to the right. And I assume MA to go clockwise. And now I'm ready to perform my calculations of this not so complicated system. So let's go ahead and actually add the distance here. So this happens to be 9 meters. And now I calculate first RAX by the sum of the forces in the x direction being equal to 0, positive to the right. 0 is equal to RAX, which happens to be a result. So I double underline it and give myself the answer arrow here. Now, RAY becomes a little bit more interesting. I do that by the sum of the forces in the y direction being equal to 0, upwards positive, and 0 is equal to plus RAY minus 60 pounds per foot multiplied by 9 feet multiplied by 1/2. Again, careful, this is it, right? Because pound per foot and foot turns out to be pounds. RAY is also in pound. So I can now calculate that this actually is 270 pounds. So RAY is equal to plus 170 pounds. Plus means it's going up as before. Nothing new here. Now, last but not least, we need to include our MA, and I probably should identify this here, MA about the z-axis. So I'm going to calculate that next. MA about the z-axis is really calculated by the sum of the moments about A being equal to 0. By the way, it's also about the z-axis. And 0 is equal to, in this case, minus MA, because I assumed it to be clockwise, minus MA about the z-axis, or again, as I sometimes like to do it, minus plus, and then the 60 pounds per foot multiplied by 9 feet multiplied by 1/2. This is the lumped force, right? So this is F resultant. But now I need a lever arm, and that lever arm now actually happens to be what? Exactly, you guessed it, it happens to be 6 meters. And I will explain that to you in a second a little bit more. But first, a rotational sense. So this rotates about this point clockwise, so therefore it's also negative. So this entire thing needs to be negative. Now, where did I get the 6 meters from? I'll show it to you one more time. I have a lumped force right here. This is F resultant, pointing downwards, and I know that it's 2/3 from this point, right? So this here happens to be the distance, which is 6 meters, which is really 2/3 times 9. And that's where I got the lever arm here. This is the lever. All right, and now I can solve that. And if I solve this correctly, I will find that my MA is 1620. In my case here, it happens to be negative. So MAZ is equal to negative 1620 pound-foot. And this is not the result yet because I know that it's 1620 pound-foot. And because it's negative, it needs to be opposite to what I said here. Don't fall into the trap to think negative means always clockwise. In fact, you see here, this is actually clockwise, right? I assumed it clockwise, which usually would be negative as indicated here, because counterclockwise is positive defined here. But I just found that this here came out to be negative. That means I assumed incorrectly here, and therefore it turns the other way around. So it actually needs to be this way, which then would be counterclockwise. So counterclockwise, and that's technically positive, like, right? So don't confuse those two things. But this now is my result, and I now successfully solved this example problem. Let me finish it by my answer arrows here, and we get a last look on it. Please understand that this 60 pounds per foot is only applicable at this high point, and then everything down here is described by pretty much this linear function. So for example, right in the middle it would be 30 pounds, and then also understand that the F resultant acts on the light side here, so 2/3 times 9, which is 6 meters, from point A. And that, I think, is everything you need to know here, and we can move on to our next topic.